Hello, this is Mr. Huff, and let's go through this virtual robotics project. All right, let's go over some overall expectations first. You're going to include a header in your program every time. Okay, you need to move 2 comment blocks into your program just after when started. The first block will have your name in it, and the second block will be the activity or the project. So describe what you're doing. So really it's just a title. There will be an activity ID, include that, and just for your reference, make sure you include, what the program is trying to do, just a quick title, okay? And another thing you need to include is, unless otherwise instructed, you're always going to have the robot put a pin down so we can track where the robot drives as you run your tasks. That way, when we look at your screenshots, we will have a very clear representation of where your robot drove during the program. Okay. The only exception to this will probably be if you're using your robot to write something. I've included a link for the pseudocode lecture, and if you don't want to watch that, you can just read the next couple of slides. You will have to do pseudocode. I would prefer that you would do this before you started programming. So design first, then build. So this slide tells you a little bit about pseudocode, and just a real quick reminder about complex behaviors, simple behaviors, and basic behaviors, and how that relates to programming. Also, I've included a link to the original Robot C lecture about pseudocode. This is what your pseudocode is going to look like. So I've given you a template. I want your simple behaviors to start with 2 forward slashes. This would be easy to transition into actual coding. And I also expect your pseudocode in your presentations to be recorded in a monospace font like Source Code Pro, Courier New, Cut of Mono, something like that. When you name your documents, so this software doesn't save anything for you. You have to make conscious decisions to save things. So I'm going to recommend that you use this naming format: activity ID, version, your last name, and then first initial. Use the dash as a separator between your terms. So here's an example: es31a-3 huff m. This tells us it's activity es31a. This is my 3rd version and my last name and first initial. I do recommend that you version your programs so you don't have to repeat work. At the start, it's not going to make a lot of difference. As your programs get more and more complicated, sometimes you'll make big changes and then discover, ooh, I shouldn't have done that. And if you download periodically and version starting at 0 and counting to whatever you need, then your life will be a lot easier if you have to backtrack and correct things. And this is how you'll save your programs to your device. So you just click on File, Save to your device. Notice if you have extensions viewed or in view, you will see VR blocks at the end. So you can see I have several programs, and you can see the version 3, 4, and 5. As we progress through these assignments, I will either require you to turn in screenshots of your program or literally turn in your program. Especially as we get more complex, then I will expect these to be submitted. When you show your pathway, this is why I have you put the pen down. What I want you to do is expand the playground, hide the data rows, use the top-down camera angle, and then take a screenshot. And it should look like this. So if you have your program written to have the robot drive into this zigzag, I can see that your program was successful in this case. So this is the first assignment. First part is going to vr.vex.com and going through the tutorials, and I would suggest this order, going from the least complicated to the most complicated. So get started using the playground window, saving your projects, using the help menus, getting examples and templates, and then how to drive forward and backward, turning, using loops, and my blocks. If you go through all of those, you'll have some basic understandings that you need to successfully complete the activities. So here's your first challenge. And what I've done is I've taken one of the activities and kind of modified it a little bit. So task 1, you're basically going to make the robot drive forward and backward 4 grids, then forward and backward 3 grids, then 2 grids, then 1 grid, changing colors of the pin every time it makes a trip. And that way we can see the different colors. The next one would be using an algorithm to go from 1 to 8 and make that into a repeating loop. So do that as an algorithm. So those are the two you can choose from. The first one is easier. The second one's a little more challenging. So you pick one and you're going to complete that. And I've given you some hints there. So to turn in your work, what you're going to do is you're going to make a real quick Google slideshow. You're going to put your project and name on the title. You're going to show me the task that you picked on slide 2. On slide 3, you're going to provide your pseudocode because you should have designed before you started programming. And this one's going to be short. Then a screenshot of your program and the playground after you run your program. And then you're going to export this as a PDF and turn it in at es31a back and forth. This is the order of slides. You'll have your title, your task, your pseudocode, and a screenshot that looks something like that. Please let me know if you have any questions and we will go from there.